Hi, this is Mr. Erlin. Today we're going to be working with homework 91, which begins with this idea of inscribed angles. So let's first remember what we learned last class. We learned that if I take a center point and I make an angle using two radii, that whatever angle measure we see for this central angle, it's equal to the angle measure of the arc. In other words, this makes 360 degrees total, and this makes 360 degrees total. So they are equal values. Well, today what we're going to do is we're going to pinch this vertex and we're going to pull it back. And as you can see it pulling back, if this were still X, this angle is getting smaller as we pull it back. And when we pull it all the way back to here, so that it then snaps to the outer part of the circle, it's gotten smaller still. And it turns out that it becomes half as big as it was over here. And this is called an inscribed angle. Whenever we have two chords meeting on the circle, creating the vertex, that angle formed is called an inscribed angle. So an inscribed angle is an angle with its vertex on the circle with two sides that are chords. This inscribed angle intercepts the arc. In other words, it creates an arc for us to look at. The intercepted arc is the arc that lies between the endpoints of an inscribed angle. In other words, if this is the angle, A, B, C is the angle, the endpoints A and C, the intercepted arc is that arc in between them. And the measure of an inscribed angle is equal to 1/2 the measure of the intercepted arc. So for example, if this length were X, this would be 1/2 X. Or in this notation, the measure of angle ABC is equal to 1/2 the measure of arc AC. And there are a couple of corollaries to that, or extensions to that. In the event that one of the sides, in the event that there is a diameter from B to C, and then from those endpoints of the diameter, B and C, I create an inscribed angle. Well, this inscribed angle is going to equal half the arc that is here, as we've just described. And if this is a semicircle, 180 degrees, then 1/2 of that would be 90. And that's kind of interesting. Let me say that again. If you have a circle and you want to find out a right angle, this is another way to construct a right angle. All I have to do is draw a diameter, which is any chord going through the center, and pick any point on that circle. And if I connect the endpoints of the diameter to those points on the circle, this angle will be an inscribed angle, and it will be 1/2 the measure of this arc. Since this was a diameter, this arc is 180 degrees. Therefore, this angle will always be a 90 degree or a right angle. If an inscribed angle intercepts a diameter, then it is a right angle. Measure angle BAC is equal to 90 degrees. And then another corollary to this idea is that if I have one inscribed angle, ABD, and I have a second inscribed angle with the same endpoints. It also has A and D as the endpoints, but it has a different point in the middle. Then since the yellow one is half the measure of AD, and the blue one, also an inscribed angle, is also half the measure of AD, then we can say that the measure of ABD is going to equal the measure of ACD. If two inscribed angles intersect the same arc, then the angles are congruent or equal. So how do we apply this? Let's take a look at this one. Number 2, it's asking us for the measure of DGF. This is an arc, and yet they've given us 3 points. Normally arcs like DE would be 2 points. So we remember that when it's 3, we're talking about a major arc. So we're going from D to F, but not the short path. We're taking D via G to get to F. We want the measure of that full arc. Well, if I look at the endpoints, I can see that there is an inscribed angle, DEF, that meets that same, that intercepts that same arc. And since this is 113, this arc will be 2 times 113, which is 226 degrees. You'll see some problems like this where there are no numbers, and that might be confusing. But PQR is an inscribed angle because the vertex is on the angle, on the circle, and the endpoints are also on the circle. And what I then do is I look at the arc that is intersected by that inscribed angle. In this case, it's a semicircle, meaning it's 180 degrees. Even with no numbers shown, I know that. Therefore, this angle must be a right angle. The measure of this is 90 degrees. You'll see that there are times when it brings in a variable. Again, LMN is an inscribed angle. If that's 67, this arc that it intercepts is going to be twice that. Therefore, this relationship, 4x plus 58, should equal twice 67. So 4x plus 58 equals 134. Subtract 58. 4x is equal to 76. And so x is equal to 80 would be 20 minus 1 is 19. There's some applications on page 2. And then on page 3 is the last thing I'm going to teach you today. In the event that we create a quadrilateral inscribed inside the shape, inside the circle. I've got a circle and I take any 4 points to make a quadrilateral. These are all straight chords. There's something interesting that happens. Let's take a look at this angle. We say that that's an inscribed angle. And therefore, let's call this, let's call this angle X. That means that this arc, which is intercepted by that inscribed angle, has to be twice that, or 2x. And similarly, let's call this Y for this angle. This is also an inscribed angle, and the endpoints are the same endpoints as the other one, just going the other direction. But that means that if this is angle Y, then this arc is 2y. What we can see then is that both of these two things, 2x plus 2y, make up a full circle. Therefore, they equal 360. If I divide everything by 2, I get that x plus y is equal to 180 degrees. And this is our theorem for quadrilaterals, that anytime we sketch or inscribe a quadrilateral inside a circle, the pair of opposite angles that face each other are going to be supplementary. If a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. So in circle P to the right, we know that measure angle ABC plus measure angle let's go with ADC equals 180. These two, ABC, this one, and ADC, this one, are supplementary. And we can say that this one, so measure angle DAB plus measure angle DAB, DBC equals 180. Therefore, we can look at, for instance, problem number 1 and say, okay, here a quadrilateral is inscribed. I can see that J and L are opposite angles. So the measure of angle J plus the measure of angle L equals 180. I don't know what J is. That's what I'm looking for. But I do know L, that's 92. Subtract that and get measure of angle J is equal to 88 degrees. And then I could do the same thing for M and K. I can say that the measure of angle M plus the measure of angle K equals 180. I know that M is 45. Therefore, the measure of angle K equals 135. And sometimes there'll be X's and things like that to get involved and make it more interesting, but that's all I've got for you today. And again, in the event that you're watching this means I'm still home and I will continue to proctor tests for those that need it. Please contact me on GoGuardian, and that way I know that you are on a Chrome device. Thank you.